All right, today we're going to pull back the curtain on this invisible force that powers pretty much everything in our lives, the electric circuit. From your phone to the lights in your room, it's the silent hero behind it all. And you'll see, understanding it is actually way easier than you might think. I mean, seriously, have you ever stopped to think about it? You flick a little piece of plastic on the wall, and boom, the whole room lights up. It feels instantaneous, almost like magic. But what is actually going on in that split second? Well, the answer is it's some kind of wizardry. It's a concept that's both beautifully simple and incredibly powerful. It all comes down to the circuit, that complete, unbroken path that lets electricity do its thing. So, to really get what's happening with that switch on your wall, we need to start small, like really small. Let's zoom in on a single light bulb and figure out what makes it glow. It's all about the flow. Okay, so what is an electric circuit? The best way to think about it is like a racetrack. But instead of race cars, you've got these teeny tiny particles called electrons. The flow of these electrons is what we call the electric current. And for anything to work, that racetrack has to be a complete closed loop. The electrons have to leave the starting line, run the whole track, and make it back home. So how does a bunch of electrons zipping around actually make light? Well, as that current rushes through the super thin wire inside a light bulb, that's called the filament, it hits a bit of a bottleneck. It encounters resistance. The filament literally fights back against the flow, and that friction creates a ton of heat. So much heat, in fact, that it starts to glow brightly. That's all it is, a simple energy swap. Electrical energy becomes light and heat. Okay, so just like any racetrack needs a starting line, the track itself, and the finish line where all the action happens, every single electric circuit is built from three essential parts. First up, you've got the source. This is the engine, the powerhouse. In a basic circuit, this is going to be a battery. It provides the electrical push, which we call voltage, that gets those electrons moving in the first place. Without a source, nothing's going anywhere. Next, you need the path. This is the actual racetrack, right? It's usually a wire made of a material like copper that acts like a superhighway for electrons, letting them move along easily. The path is what guides the current from the source to its destination and all the way back again. And last, but definitely not least, you have the load. Honestly, the load is the whole point. It's any device that grabs that electrical energy flowing by and turns it into something useful, like light from a bulb, sound from your speakers, or, well, everything your computer does. So we've got our three core components, source, path, and load. But here's the thing, just having the pieces isn't enough. How they connect, and maybe more importantly, how they disconnect, is what really matters. And that brings us right back to our friend, the light switch. This is the key. A closed circuit means the racetrack is complete. It's a perfect loop, so the electrons can flow, and bam, the light bulb turns on. But an open circuit, that means there's a gap. The racetrack is broken. The electrons get to the edge, can't make the jump, and everything stops. The bulb stays off. All a light switch does is act like a little drawbridge, opening or closing that gap whenever you tell it to. Now, you can probably imagine that drawing actual pictures of batteries and wires would get pretty complicated, especially for something like the circuits in your phone. So engineers came up with a kind of shorthand, a universal visual language called a schematic diagram that anyone in the world can understand. And this language is actually super simple. Instead of a detailed drawing, a battery just becomes a set of long and short parallel lines. A wire is just, well, a line. A bulb is a little circle with a loop inside, and that switch we've been talking about, it's drawn as a line with a little break in it, perfectly showing how it opens and closes the path. With just these few symbols, you can map out ridiculously complex circuits. Okay, knowing the theory is one thing, but when we talk about the circuits in our homes, we're moving into the real world. And the current flowing through your walls is way, way more powerful than what's in our simple battery example. So it's absolutely critical to know how to be safe. And these rules aren't just suggestions, they're essential. That whole octopus connection thing, if you plug too many high-powered devices into one outlet, the wires inside your wall can literally overheat and start a fire. And the reason you never, ever mix electricity in water is because water drastically lowers your body's resistance, making it a much easier path for electricity to travel through you. And trust me, that's not a path you want it to take. So, we've got the basics of the circuit, and we know how to be safe. Now, let's zoom out, way out, because every single one of those circuits in your home, your school, your city is part of a much bigger picture, global energy use, and the need to conserve it.
So why does saving a little electricity here and there matter so much? It really comes down to two big things. First, our planet. A lot of our electricity still comes from sources that create pollution. So if we use less energy, we have to generate less of it. And second, something a little closer to home, your wallet. The less energy you use, the lower your electricity bill. It's a true win-win.
To put this into perspective, take a look at this number, 45 watts. That's about how much power one TV might use. Seems small, right? But now, start adding it all up in your head. The refrigerator, every light that's on, your computer, your phone charger, every single one is a load on the circuit, and all those watts add up incredibly fast. But here's the good news. Making a difference is actually pretty simple. We're not talking about huge sacrifices. It's about small habits. Just flicking off lights when you leave a room, swapping old incandescent bulbs for energy-efficient ones. Oh, and unplugging your chargers, because yeah, many of them still sip a little phantom power even when your device is full. These small acts, when we all do them, have a massive impact.
So there you have it. We've gone from a single tiny light switch all the way to the global power grid. Hopefully the next time you flip a switch, you see it a little differently. Not as magic, but as you personally completing a circuit. So my question for you is, as you go about the rest of your day, what other invisible circuits are you going to start to notice working all around you?